Hello, today we're going to talk about 7.5 exponential and logarithmic equations. Of course, I'm going to split this into 2 days, and today we're just going to focus on log equations, so we're going to call this 7.5a. Alright, so the first thing you want to do when solving equations is you want to get it as log equals a number. Okay, so again, log equals a number. So in this first equation, we can combine those through division. So we get log base 4 of x divided by 2 equals -1. Once we get it as a log equals a number, we can do our loop-de-loop. And then we get 4 to the -1 equals x over 2. Well, 4 to the -1 is just 1/4. And then we multiply by 2, so 2 times 1/4 is 2/4 or 1/2. So x equals a half. Alright, and then you always want to make sure that you check them. So you can check it by plugging it into the original equation. So we get log base 4 of 1/2 minus log base 4 of 2 equals -1. And you can check this simply by plugging it into your calculator, right? This part ends up being, let's see, -1/2, and then this part ends up being, well, 1/2. So then you have -1/2 minus a half, and it equals -1. All right, so let's do another problem. Let's do number 2. So we can combine these logs by multiplying them. So log 2x times x equals 2. All right, we do our little loop-de-loop, but we have an issue. We don't have a base, right? So what, that's just 1, right? Nah. All right, it's 10. Okay, hopefully you remember that. Okay, if the base isn't written, it's base 10. So we have 10 to the second power equals 2x squared. So we have 100 equals 2x squared. So 50 equals x squared. So x equals the square root of 50. You reduce that, you get 5 square roots of 2. What did we forget? Technically speaking, whenever you take the square root, you've got to do plus or minus, right? I've always told you that. Okay, so there are 2 answers. However, when we check them, okay, you always want to make sure that you check the plus or minus ones, right? Because they're tricky sometimes. When you plug them back in, this part, that 2 times x, this x, that can't be a negative number. It's always log of something positive. So, negative isn't going to work, because if I plug it in, it's -10 square roots of 2, and this is -5 square roots of 2. So that ruins it, right? So -5 squared of 2 won't work, right? Because the argument, that little part, the of part of the log base 10 of 2x, all right? Because the argument can't be negative. Now, that doesn't mean x can't be negative. Sometimes you can solve and x can be negative, but when you plug it in, you can't get negative arguments. Okay, so just be careful there. So this answer is only positive 5 square roots of 2. All right, let's do another one. All right, so on number 3, you want to multiply, so we get log base 3 of x times x minus 6 equals 3. We do our loop-de-loop. We get 3 to the third power equals x times x minus 6. So we get 27 equals x squared minus 6x. Notice that x squared and x, that means we could use the quadratic formula or factoring. okay, or completing the square, lots of options. I like to factor. Let's see, is that right? Yeah, it adds up to -6, multiplies to -27. So x is either 9 or x is either -3. However, if we plug it back in, -3 isn't going to work. Okay, so our answer is just 9. If you plug it in, it should work. So log base 3 of 9 plus log base 3 of 9 minus 6. So log base 3 of 9, plug it into your calculator, is 2. And log base 3 of 3, well, when the argument and the base are the same, it's just 1. And 1 plus 2 is 3. So it's good. So your final answer is 9. All right, there is another way to solve logs. Instead of getting it as log equals a number, you could have log equals log. This follows the same rule that we have with exponents. So if I had 2 to the x equals 2 to the 5th, well, x has to be 5, right? This is not going to equal 2 to the 4th. This is not going to equal 2 to the -5. It's not going to equal anything but 2 to the 5th. Okay? That x has to be the same. Same goes for logs. If you have log m equals log n, the arguments are the same. But notice the bases are the same. So if the bases are the same, the arguments are the same. Okay. So let's try this example. So instead of getting, again, we could get all the logs onto one side and solve it just like the first two problems. Okay. Another way is make it log equals log. So log base 5 of x equals, well, first you got to move that 3. So then we get log base 5 of 2 to the 3rd power is 8. So then we do 8 times 7. And that's log base 5 of x. So log base 5 of x equals log base 5 of 56. So if the bases are the same, you essentially chop off the logs and you get the arguments are equal. So x equals 56. And we can plug it back in and notice we get a positive argument, so it should be good. All right, so here we can solve this a couple different ways. Go ahead and practice it on your own. All right, so what I would do is I would start by multiplying. So you have x plus 1 times x minus 5. We do our loop-de-loop. 7 to the 1st equals x plus 1, x minus 5. So 7 equals, make sure you FOIL that correctly. Let's see. And then I would get everything to one side. And that is, what, -12. See if I can factor it. Perfect. So you should get x equals 6 or -2. All right, when we plug it back in though, -2 runs into an issue. So we throw that out. Again, we don't throw out every negative. It's only when the argument is negative. You plug in 6, 6 should work. Okay? Now let's say you like solving it when it's log equals log. Okay? You can do it the same way. All right, it's very similar. It's just you're knowing your rules. So you still start it the same way. You get log base 7 of that x plus 1 times x minus 5. But on the other side, if we want to make that into a log, all we need to do is multiply it by the same base and argument. So essentially, if we multiply it by log base 7 of 7, well, that's just multiplying it by 1, right? Log base 7 of 7 is 1. So this is 1 times log base 7 of 7. So it's just log base 7 of 7. Okay. X plus 1, x minus 5. And notice we're getting the same thing. You cross off the bases. Ooh, sorry, pressed the wrong button there. And then here, you get x plus 1 times x minus 5 equals 7, which is what we had here. So it's just a different way of looking at it, okay, if you wanted to do it as log equals log. Oh, different way. All right, so why don't you try this one? Okay, again, a couple different ways you could approach it. Let's see, if you want it to equal a number, we could do 1 equals log base 3 of x minus log base 3 of x minus 4. Then we get 1 equals log base 3 of x over x minus 4. Okay, so this is essentially, let's just put that over there. Okay, so then we do our loop-de-loop. We get 3 to the first equals x over x minus 4. Don't like the fraction, so I'm going to multiply it by the other side. And now I just solve it like a regular equation. All I got to do. There's an answer. We plug it back in and we should get the same answer. All right, but let's see if I wanted to do it as all logs. We could do log base 3 of x minus 4 plus 1 times log base 3 of 3, because that's the base we have now, equals log base 3 of x. So we get 3 times x minus 4, or I'm sorry, log base 3 of that equals log base 3 of x. Cross off your bases, right, because you have log equals log. So you get 3 times x minus 4 equals x. And notice that's what we had right there. So our answer is 6. All right, so hopefully you know how to solve log equations now. If you have any questions, feel free to talk to me in class.